Right, in this lesson, we shall solve this particular question on vectors, right? The position vector of a point P is 3 and 4. Given that the point Q is -1 and 1, find the vector PQ. And we proceed to solve this particular vector question as follows. Right, to draw actually, or to solve this particular question, we first draw a diagram. And we draw this particular Cartesian plane as shown here. We mention the existence of a point P, right, whose position vector, right, is 3 and 4. So in other words, we have O here, we have the point P, but we accept that the point P has the position vector, meaning that OP is actually, as mentioned here, it is 3 and 4. So we write here 3 and 4, like so. Okay, right now, moreover, it then means a couple of things. It means that this point P will have the coordinates 3 and 4, like so. Moreover, you are given additional information, right? That given that the point Q is -1 and 1, there's a point Q that sits somewhere here. On these points, you can put it a little bit lower. It's okay. Can just relative to the point P in height, you can put it a little bit lower somewhere there, so that there is a point Q whose coordinates are -1 and 1. And here is the point, and we can join the point Q with the origin. Okay, just as shown there. There are a couple of things that the examiner wants. The examiner is interested in us now finding PQ, so we wish to move from P to Q. In other words, we actually therefore need to deal very carefully with directions. We want to find the vector from P to Q, like so. Right, so if we want to find the vector from P to Q, we can do it in a couple of ways, and this is how we can reason this out. We can change the direction of this vector. Instead of looking at the position vector OP, we can look at it as PO, and we can look at this vector here as a vector from O to Q, so that in the end, then to find PQ, we can look at this as PO and OQ. Okay, so there's a couple of there are a couple of things that remain extremely important. So in other words, to find the vector PQ, we can actually deal with the vector PO like this, and we add to it the vector OQ as well, and we add them up as shown there. So that in the end, then you have the vector PQ, which is the same as what? Right, PO itself. Now, we know that OP is 3, 4, which means therefore now if we consider PO, the opposite of this vector, it's just going to have negative components, like so. Right, plus the vector OQ. Right, now the vector from O to Q, and if we look at the vector from O to Q, there are a couple of things. So what we do is with these vectors from O to Q, we actually take the final point minus the initial point. The initial point is the origin. So in other words, you can then say the vector OQ, the final point would have -1 minus 0 and then 1 minus 0. We are taking the final minus the initial. Okay, now this is good, but so good. -3 minus 4 plus -1, 1, which is -3 minus 1, which is -4. And then we have -4 plus 1, -3. And this therefore means the vector PQ is this one. And we can conclude and then say, hence, right, hence the vector PQ is the same as what? Is the same as -4 minus 3. -4 minus 3, like that. Okay, there are a couple of things then that remain critically important. And how do we then determine the vector PQ differently? Because we can really determine the vector PQ differently. For example, because we can see that in this particular vector diagram, we can decide to say, okay, to find the vector PQ, we're going to proceed as follows. So in other words, there's an alternative way to look at this particular question. So we still have the vertical axis and we have the horizontal axis like so. And then now we have this one here, the point P, which is 3 and 4, like this. Okay, so we have the vector that points in that direction. We have the origin here, which is the origin of 0 and 0. The point Q is a little bit obviously not as high as P relative to the origin. And this one, and it has the coordinates 1 and 1. And now we want to find the vector in this direction. And now we can then say, how do we then find that? Yes, we've seen that we can actually look at these vectors in either way. So, I mean, we decided to say, okay, we can look at the vectors this way. So to move from P to Q, we can move from P to O and then from O to Q. Now, in other words, we have the following, right? So alternatively, what then can we do here? All right, what then we can do is to consider the vector PQ straight away. Right, to find the vector PQ, we can then say we wish to consider the points P and Q. And then we take the final point, because we're moving from P to Q, we take the final point. Okay, so it has the first component -1, and then the first component -3 there. Here, the first component is 1, and the first component is a 4. So which is, we add this here, we have -4, and then we have -3. And we are able to see, but very, very clearly, that these particular vectors here, the vectors, the vector PQ determined in using different methods, are actually obviously the same vector. We are able to therefore celebrate and say, thus, right, thus, the vector PQ, which has so much been desired, is actually of the required result. And it is, as obtained here, it is a -4 and -3. So it is -4 and -3 like this. And this is the result. And this is what we asked to do. Right. So thanks everybody for watching, and goodbye to you. Goodbye. Right.